Hi there, my name is Pierre Laperdrix. I'm from CNRS in France, and I'm really happy today to present our paper Fingerprinting in Style Detecting Browser Extensions via Injected Styles. This work was done with Oleksii Starov from Palo Alto Networks, Quan, Chen, and Alexandros Kapravelos from North Carolina State University, and Nikiforakis from Stony Brook University. The browser extensions are small programs that extend the capabilities of a browser. You can find them in official stores like Chrome Web Store or Firefox browser add-ons, and the most popular ones include ad blockers, password managers, or download helpers. So this paper is on browser extension fingerprinting. So what is it? The fingerprinting of browser extension consists in building a list of extensions that are installed in a user's browsers. And what's particular here is that there are no APIs in the browser to get that particular list. We use side effects of extension to identify them, but we cannot basically get that list directly from the browser. And so who can fingerprint extension? Well, any website with JavaScript can try to fingerprint extension. There is absolutely no need for permissions to do that. And so what is the implication of detecting the list of installed browser extension? Well, first, it can complement existing browser fingerprinting techniques. So on top of the HTTP headers that we know or the JavaScript attributes that we can collect, we can add to that list the list of installed browser extension. And so if this list is highly unusual or even unique, well, it can lead to user identification on the web. Also, knowing the list of installed extension can reveal personal information, like the use of a specific software or services. So for example, some extensions include like VPN, the use of password managers. Also found during this study the example of a countdown extension that count down the days until a baby is born. But we also have extension maybe also related to religions. So what I want to say with this slide is that detecting the list of installed browser extension raises privacy issues because we can learn a lot of information about the users and its habits. Before I dive into the related work, I need to present the architecture of a browser extension. And so the main file of the extension is called the manifest. It's a file that provides metadata information like the name of the extension, the version or its description, but also it has different sections related to how the extension works. So for example, there is the background page that implements the long-term logic of the extension. So as soon as you start your browsers, all the background page of the different extensions that you have will kick in. You also have content scripts that are injected into the different web pages that you visit. And also we have what we call web accessible resources, which are files like just libraries or images that can be accessed by the extension, or they also can be accessed by different web pages that you visit. And so before our work, there are like 3 different techniques that I want to talk about that already try to fingerprint the list of installed browser extensions. So the first is called WAR fingerprinting. So basically by probing very specific URLs, you can detect if the extension is installed or not. So this URL have to be built with the extension IDs and the specific path of the file of the extension. And so today this technique is really the strongest one to detect browser extensions, but with the introduction of manifest v3 in Chrome, there will be access control on these web accessible resources, and it probably will mitigate a lot the effectiveness of this technique in the future. The second method is behavioral fingerprinting. So basically you recall what an extension does on a page, like does the extension add some node, remove them, or even modify existing node, and by having this behavioral fingerprint of the extension, you can find it in subsequent visits. The third method that also exists is with sparse messages. So with specially crafted messages, we can learn if an extension is present in the browser or not. And so In our study here, what we will present is how we can detect extensions through style modifications. So an HTML web page is a simple file that mixes HTML elements with JavaScript code and some CSS directives or rules. And extension can customize the way the page looks by inserting, CSS rule as content scripts on a page. And what I want to point out here is that while some rules can, be active on all web pages, some others will be only active on very specific URLs. For example, if you have an extension that only works on twitter.com, well, the CSS rules and the style sheet will only be injected on web page from twitter.com. So that means that even if we have a very big data set of extensions to analyze, if we detect, some CSS content scripts in the manifest file, not all of them will be detectable with our technique. And so to better understand how our technique works, I've taken an example from the Wiki1. So Wiki1 is a website that optimizes the reading experience on Wikipedia. So on the left, we have the device fingerprint page of Wikipedia. And on the right, we have the Wiki1 equivalent. And so Wiki1 provides an extension that basically replaces Wikipedia links with Wiki1 ones. And today the extension has more than 200,000 users. And so if we take a look at the manifest.json file, so we can see in the first part that there is some meta information like the version, the description, and the name of the extension. After, we also see a small section which is the background section, but what we are interested in is the content script one. Here, if we look at it, we can see that there are two CSS files that act as content scripts. So Auto1 has 18 CSS rules and cards as 20 CSS rules. And if we look at the matches section, it indicates that the two CSS files will be injected on all HTTP and HTTPS web pages visited by the user. So that means this extension, we can try to identify it on any web page, on any domain on the web. And the last section, which is run at, indicate that the style sheets will be injected as soon as the DOM is loading. So if you have a fingerprinting code, you don't need for the web page to be fully loaded to run it. You can run it as soon as the page is being loaded. And so how do we detect extensions through style modification? Well, here we have taken an example from the cards.css file. So the first line is the selector of this rule, and below that are the different properties that this rule modifies. And in order to know if the extension is installed or not, we created a structure that will react to the specific CSS rule that we want to test. So we basically, here we created a div with the ID www_overcard and another div with the class www_image, and then we finally added the image element. And what I want to point out here is these two specific attributes. There is margin, which is set at 10 pixels, and border radius, which is set at 2 pixels, because we're going to use it in the next slide. And so how do we detect if the extension is installed? Well, we basically use the structure that I've just described and look at the style of the image. So when the extension is not installed, if you look at the style here, there is almost nothing. We know that the height and width are 0 pixel and display is in line, but there is not much more than that. And if we look at the same properties, but with the extensions installed, this is a very different story. We can see that there are a lot of properties that are already defined when we get the style of the image. And if you look specifically at border and margin, we find again the 2 pixel and 10 pixel values that I just presented on the previous slide. So basically, by checking the style of an element, we can know here in this case if the Wiki1 extension was installed or not in the user's browser. And so in order to test our technique, we collected 116,000 different extensions, and we tested our technique and also the three techniques that that I presented in a related work. And our findings basically reveal that each method is really complementary to one another. Some extension can be identified with very different techniques, but also some extension can only be identified with one technique. And so regarding CSS fingerprinting, our technique was able to detect 4,446 extensions, and 1,074 of them were identifiable only through CSS fingerprinting. And so because of time, I cannot dive deeper into our paper, but if you read the rest of the paper, what can you find? Well, we have details on the framework that we built to detect fingerprintable extensions. We also provide a longitudinal analysis of the fingerprintability of extensions over time. We also explain the reason behind the collision that we find with the different style fingerprints that we collected. We also look at the performance of our technique, so how many extension can you detect with our technique, like how fast is it? And finally, also we detail the two different strategies that can be used to protect against style fingerprints. So one is located at the extension level and another one at the browser level. And so here are two links. The first is the link to our paper, and the second is a link to our artifact. So artifact contains a lot of different data. So it has a demo of our fingerprinting technique. We also provide a different prototype. This is an extension that you can run in your browser, and you can also find the complete data set of more than 100,000 extensions if you want to repeat our experiment. So thanks a lot for listening, and if you have any question, don't hesitate to contact me. I will be happy to answer any question that you may have. Thanks.